Assalamualaikum warahmatullahi wabarakatuh and good day. So for this part, we are going to learn about still it's subtopic 3, continuous random variable. But our focus will be on to solve or find the cumulative distribution function and solve related problem. Okay, so what is cumulative distribution function? So for the discrete, we know that we just have to add up between the frequency of that class with the previous cumulative frequency. That is for the data. But for the random variable, we need to add up the probability. Okay, so how about for the continuous random variable? So what is cumulative distribution function for the continuous random variable? So let's see, if x is a continuous random variable with probability density function, small letter f of x, then the cumulative distribution function is given by capital letter of f respect to x, where first of all the probability of x less than or equal to a is equal to capital of f a. So this part, it will be the same as the discrete random variable. Okay, we represent the cumulative function as capital of f. And then the second part, for this part, it will be different. Why? Because probability of x from x1 to x2 is the same as capital F of x2 minus capital F of x1. So this part we don't have to take care about the we don't have to care about the equal or no equal sign in the inequality. Why? Because it will be the same, nah? Okay, but for discrete it is important. So this part is actually the same as probability of x not include x1 and x2. Also the same probability of x, okay, the same as probability of x not include include x1 but not include x2, or probability of x not include x1 but include x2. Okay, it will be the same now because for continuous we don't have a certain value for a certain x. Okay, and lastly the PDF, which is the small letter of fx, is equal to the derivative of the capital of fx, which is equal to f prime, capital F prime x. Means that to get the PDF back from the cumulative distribution function, we can just differentiate the cumulative distribution function. So, how to find the cumulative function? So, x is a continuous random variable with probability density function. So we have the PDF here, which is represented by small letter of f of x, which is equal to 1 over 4 multiplied by 4 minus x for x in between 1 to 3 inclusively. So now we want to find the cumulative distribution function. So this is the step where we need to do to find the cumulative distribution function. First of all, we need to draw the real number line. Okay, so we have the real number line. First of all, from negative infinity to infinity, we can separate into 3 parts because we have one defined function in between 1 to 3. How about before 1? So we don't have function, so we put 0 as the function. And so for x more than 3, we put 0. Okay, so how do we find out the cumulative distribution according to this number line? Okay, first of all, we need to find out the cumulative distribution function for all these 3 intervals. First of all, for the distance for the value of x less than 1, the first interval. Okay, this is the second interval, this is the third interval. The first interval for x before less than or equal to 1. What you need to do is to put any x before 1. Okay, so the function will be the probability of x less than or equal to x, means that we have to integrate from negative infinity up to x. Okay, with the function 0 respect to x. So what do we have? Let's integrate from negative infinity up to x respect to x of function 0. Okay, because this is what we need to do to find the probability for fx. Okay, but we need to find up to x. That's why we have upper limit x. So differentiate 0, we get 0. Okay, we don't have function there. Okay, now this is easy. For the second interval, in between 1 and 3 inclusively. Okay. Oh, before that, we need to conclude that up to 1 here, the capital F of 1 is 0. So means that if we want to find F0, it will be 0 also. If you want to find F1, it will be 0 also. Okay? You need to find because we need to use it for the second interval. Remember, in the discrete, we need to know what is the cumulative to include the next part of the interval. Okay, now for the second interval in between 1 and 3, okay, so how do we find the cumulative distribution function? So it will be starting from negative infinity up to any x in between 1 and 3. So what we need to do, we need to integrate from negative infinity up to x. But because we have transit, okay, change of function at 1, at x equal to 1 means that we have to integrate both parts. But we know this part is actually capital F of 1. So to get capital F of x for this interval, it will be capital of F of 1 adding up integration from 1 up to x. So plus with integration of up from 1 to x of a function. What function we need to use? The function of 1 over 4 multiplied by 4 minus x respect to x. Okay? So what we need to do, we just have to integrate one part because we know already what is f, capital F of 1, which is equal to 0. So it will be 0 plus with, so integrate 4 minus x will be 4x minus x squared over 2 from 1 to x, and then multiply by constant 1 over 4. So substitute the upper limit x and lower limit 1, we get, so 1 over 4 we can bring it in, or you can just put it later. So if you want to bring it in, so what do we have? It will be 4 over x over 4 is x minus x squared over 8 from 1 to x. So substitute the upper limit, we get x minus x squared over 8, and then substitute 1 into the function, we get 1 minus 1 over 8. So 1 minus 1 over 8 is equivalent to 7 over 8. So the function will be x minus x squared over 8 minus 7 over 8. Okay, so we find out already what is f of x for the interval 1 to 3. And then after that, what we need to do? We need to find the upper limit of this interval. Why? Because we need to find for the next one. Okay, if we find out the upper limit up to 3, because the interval stop at 3, right? So we need to find of capital F of 3. Which is, if we substitute the value 3 here, 3 minus 3 squared over 8 minus 7 over 8, this is equivalent to 9. 9 minus 7 is 2. 2 over 8 is, do we get the same, do we get the correct value? Minus 7 over 8. Can we check together? Is this correct? 3 minus 9, 3 squared over 8 minus 7 over 8. Oh, sorry. 9 and 7 is equivalent to negative 16 over 8. Okay, sorry. So 3 minus 16 over 8, this is equivalent to 2. So 3 minus 2 is equal to 1. That's why we get 1. Okay, so let me write down this back. Yeah. Okay. So, capital F of 3 is equal to 3 minus 3 squared over 8 minus 7 over 8. So, 9. So, it's equivalent to 3 minus 16 over 8, which is, this is equivalent to 2, which is equal to 1. So, now for the last interval, we need to find the function where we need to integrate from negative infinity up to x. So, where is our x? So, our x will lie after 3. So this is our x, right? So we need to integrate from negative infinity up to x. But we know we will transit at 1 and 3. So the latest one is F3. Okay, so we just need to integrate here to here from 3 to x. Okay, so for interval x more than or equal to 3, capital of fx will be f3 plus with the integration from 3 up to x of function. What function we have here? It's 0 respect to x. So we know already this is 0 and f3 is equal to 1. So the answer is equal to 1. Okay, so this is how we find out the cumulative distribution function for continuous random variable. But now, how do we need to just left this as it is? No, we need to write down back what is the final function kita. So capital F of x is equivalent to, put it in bracket. The first one will be for the first interval x less than 1, which is equal to 0. Okay, and then the second interval 1 to 3, our function is x minus x squared over 8 minus 7 over 8. And then the last one for x more than or equal to 3, the function is equal to 1. So for cumulative, it always starts with 0 and end with 1. Okay. Okay, so using capital F of x to find probability of x in between or from x1 to x2. So the cumulative distribution function can be used to find probability of x in between x1 to x2 inclusively as follows. So if we want to find probability of x less than or equal to x1, directly we can use capital F of x1 because this is representation of the cumulative lah, directly. But if you want to find probability of x in between x1 and x2 inclusively, so what is x1? This is x1, this is x2, right? We want to find in between here. Okay, so we know cumulative of f2 is from negative infinity up to 2. This is f2. And then f1 also is from negative infinity up to 1, x1. Sorry, x1. This is x2. So we can find the middle area here by subtracting fx2 minus with fx1. Okay, and then probability of x in between x1 and x2. So this one exclusively, right? So we use the same formula for the inclusive intervals. Okay, because it's a continuous, so it doesn't matter. And then the same for the probability of x in between x1 and x2, where x1 must be included. And also the same as probability of x1 up to x2, exclude x1. Okay, so here, even though you don't have equal sign or one of it only have equal sign, it will be the same lah. Okay, it's always the same, capital F of x2 minus capital F of x1. Okay. Let's continue with the example 2. The continuous random variable x has the probability density function defined by. So we have a PDF here. So we have a function at 3 intervals, defined at 3 intervals. So if we do it on the real number line, we will have 0 up to 1, 1 up to 2, 2 up to 3. So we have 5 intervals. The first one less than 0. The second one in between 0 and 1. And then the next one from 1 up to 2. And then from 2 up to 3. And then 3 and above. So we only have 3 functions defined. 1 over 2 here. This is negative 1 over 2x plus 1. And then here is 1 over 2x minus 1. Okay, so find the cumulative distribution function of capital F of x, hence determine. So now the question is to find the cumulative distribution function first. We cannot directly find the interval, find the probability without finding the cumulative distribution function. Okay, even though you know, oh, we want to find the probability, we just have to integrate lah. No, we have to find the cumulative distribution function first and then hence determine the probability. Okay, our first work is to find the cumulative distribution function. So how to find the cumulative distribution function? We just follow the step we do in example 1. First of all, each of the intervals should have the cumulative distribution function. So the first interval here is for x less than 0. So where is our x? X will lie in interval of x less than 0. So we want to find the function, we just have to integrate from negative infinity. So it will be starting from negative infinity up to x, where x doesn't intersect with any of function. First interval only. So integrate from negative infinity up to x over function 0. So we get 0. So f0 is 0. Why? 0 is the upper limit of the x. The biggest value in the interval. Okay, next one. We want to find for the x in between 0 and 1. Right? So our x will be around here. So to find the cumulative means that we need to integrate from negative infinity up to x. But we have transit. Where is the transit? We have to change the function from 0 to 1 over 2 at 0. So what we can find for the interval 0 to 1, the capital of fx is, we start with f0 first. So because we find out already f0 at the first function, and then we add up, continue from 0 up to x, which is by using the function 1 over 2 respect to x. So f0 is 0, so 1 over 2 integrate, we get 1 over 2x, and then substitute 0 and x, so we get 1 over 2x, which is x over 2. Okay, so settle for the second interval. The third interval will be in between 1 and 2. So to get the cumulative distribution function, we need to integrate from negative infinity up to x. But we have transit at 0, at 1. Okay, the biggest is the at 1. So we can find capital F1 first. Because for the second interval, we have the value of x equal to 1, right? So we find out capital F of 1 first, which is equal to 1 over 2. Okay, so the next interval, we just have to put the capital F. We can just directly put capital of F1 plus with, so this is our x, right? So the latest transit is at 1, so capital F of 1, and then add up from 1 to x with the function of negative 1x plus 1. Negative 1 over 2x plus 1. So we just have to integrate once for each of the function. F1 is equal to 1 over 2. So plus with, integrate negative 1 over 2x will be negative 1 over 2x square. Negative 1 over 4x square, and then plus with x and substitute x and 1. So we get negative x square over 4 plus x minus negative 1 over 4 plus 1. So this part is equal to 3 over 4. So 1 plus 2 minus 3 over 4 is equivalent to negative 1 over 4. So we have negative x squared over 4 plus x minus 1 over 4. Okay, so for this interval, the highest value we have will be, the interval we have, the highest value is 2. So we find out what is capital F of 2, which is, after we substitute the value, we get negative 2 squared over 4 plus 2 minus 1 over 4. So this is equivalent to 4 over 4, so negative 1. Negative 1 plus 2 is 1. 1 minus 1 over 4 is 3 over 4. Okay, so this is for the third interval in between 1 and 2. And then the next one is the fourth interval. Will be in between, yes, in between 2 and 3. So the x in between 2 and 3, we need to integrate from negative infinity up to x, and the latest transit is f of 2. Okay, so we just have to find the cumulative by finding the capital F of 2 plus, so continue the integration from 2 to x with the function of 1 over 2x minus 1. So we know capital F of 2, earlier we find out already, which is equivalent to 3 over 4. And then we just need to integrate 1 over 2x minus 1. So we get 1 over 4x squared minus x. So substitute the upper limit x and lower limit 2. So we have 3 over 4 of x squared over 4 minus x plus with x squared over 4 minus x. And then minus with, substitute 2, we get 2 squared over 4 minus 2. So this part will be 1. 1 minus 2 is negative 1. So negative is adding up. So we have x squared over 4 minus x, and then plus 7 over 4. Okay, so this is for the second one. The fourth interval. So the upper limit of this interval is f3. So we can find out what is capital F of 3. So if we substitute the value, we get 3 squared over 4 minus 3 plus 7 over 4. So this is 9 over 4. 9 plus 7 is equivalent to 16 over 4 minus 3. So 16 over 4 is 4. 4 minus 3 is equal to 1. Okay, last interval, the final interval will be for x is more than or equal to 3. So this is our x. So the latest transit will be at 3. So kita boleh cari capital F of 3. So which know already is equal to 1. And then continue integrate from 3 to x. So which function we need to use? Yes, function 0. Okay, so we have integration of 0 respect to x from 3 to x is equal to directly equal to 0. So f3 is equal to 1. So we have the answer which is equal to 1. Now we find out already the cumulative for each of the interval. So we need to write down the final answer lah. So the capital Fx can be written as 0 for interval x less than 0. X over 2 for the interval 0 to 1. And then negative x squared over 4 plus x minus 1 over 4 for interval 1 to 2. And then x squared over 4 minus x plus 7 over 4 for x in between 1 to 3. And lastly, 1 when x is more than or equal to 3. So this interval, you have to follow the PDF lah. PDF interval. Don't change the equality sign, inequality sign, okay? Okay, so now we can write down the answer for the probability. So, because we want to find probability of x less than or equal to 1.5, this is equivalent to capital F of 1.5. So, which function we should use? Okay, so you need to know for the interval 0, 1, 1, 2, 2, 3. So, which interval that this value will lie? So, it will lie here, 1.5. So, you need to use capital F of x for the interval in between 1 and 2, which is here we get negative x squared over 4 plus x minus 1 over 4. Okay, so this function is negative x squared over 4 plus x minus 1 over 4. So substitute 1.5 into the function, we get the answer equal to 11 over 16. Okay, now for question B, we want to find probability of x more than 1.5. So we don't know we don't know how to find it by using cumulative if it's more than, because we know that capital F of x is equivalent to probability of x less than or equal to x. Okay, but we know we can find out by using the complement probability. This is equivalent to 1 minus. Why? Because for x more than 1.5, this should be 1.5. So it's if it's more than, then it's complement for less than or equal to. So you can just subtract for the probability of x less than or equal to 1.5. Okay, 1 minus probability of x less than or equal to 1.5, which is this part can be written as capital F of 1.5. So we know already from question A, cumulative function for x equal to 1.5 is equal to 11 over 16. So 1 minus 11 over 16 is equal to 5 over 16. That's for question B. For question C, they ask you to find probability in between 0.5 and 1.5. Okay, on our number line, we have different function for 0 to 1 and 1 to 2 and then 2 to 3. Okay, 2 to 3. So you need to recognize which interval is this. So it starts from 0.5 up to 1.5. So we have transit in between 0.5 and 1.5. Or you also can directly use from 0.5 to 1.5. The cumulative will be around here. It's less than, right? So to find the interval, you can subtract the bigger one, which is capital F of 1.5 minus with capital F of 0.5. But remember, we need to use the correct function for each the value. Okay, so 1.5, we need to use the function for the interval from 1 to 2, which is negative x squared. Okay, negative, because this function is negative x squared over 4 plus x minus 1 over 4. And then for 0.5, our function here is x over 2. So minus with 0.5 over 2. Okay, so this is capital F of 1.5. This is for F of 0.5. Okay, so don't use the incorrect function. Okay, please choose it correctly. So the final answer will be 7 over 16. Okay, lastly for question D. We want to find the probability of x in between 0 to 2.5. Okay, so where is 0 and 2.5? Okay, so on the real number line, this is 0, 1, 2, 3. So 0 up to 2.5. Right? So we can find out by finding the probability capital F of 2.5 here minus with capital F of 0. Right? But we know already capital F of 0, we don't have function before this, so the probability will be 0. So directly it's capital of F of 2.5. Okay, here we use function of x over 4, x squared over 4 minus x plus 7 over 4. So substitute 2.5 into the function minus with 0. F0 is 0. So we have the answer of 13 over 16. Okay. Okay, so please choose the function correctly according to the interval. Okay, so let's continue with example 3. So the random variable x has a cumulative distribution function given by... Okay, now because we have a cumulative with a function, not a value, so this is a continuous random variable. Okay, so we have to make sure we know that this is a continuous random variable. Okay, now we have all this function, the cumulative function, the piecewise function, or the cumulative distribution function. But now we have unknowns in two of the functions. Okay, piecewise function. So of course we need to find what is A and B first, if before we find out the probability of anything, right? So how to find A and B? What can we relate? Okay, remember earlier we know that on the interval we can find the capital of 4. Let's say here is capital of 4, and then also the next interval will also have capital F of 4, right? So these two values must be the same. Okay, even though we use the second function and the third function, the value should be the same for 4. Okay, because it's the limit of the interval. Okay, the same for x equal to 2. So for capital F of 2, if we use function 0, then it will be the same of capital F of 2 if we use the second function. Why? Because both have the value of x equal to 2. Okay, so by using that properties, we can find out what is value of A and B. So to find the value of A and B, and then next we need to find the probability density function, means that we have to go back to the PDF. And lastly, to find the probability of x in between 3 and 6. So to find the value of A and B first, to find the value of A and B, we have all of these 4 functions on the 4 interval. Okay, but as earlier we know that we can find out the value of A and B because at certain interval, at certain value at the end of the interval, endpoint of the interval, it will be, we have two choices now. The first one, we can use the right function, or the second one, we can use the left function. So we can equate. For the capital F of 13, we know it will equivalent to 1, and it also equivalent to 13 over 10 plus B. So will be 13 over 10 plus b equal to 1. So b is equivalent to negative 3 over 10. Okay, we find out already what is b. How about a? For a, we can use value 2. Why? For 2, we can use function 0 or function ax minus 10, minus 1 over 10. So for f of f2, it will be equal to 2a minus 1 over 10 equal to 0. So 2a equal to 1 over 10, then a is equal to 1 over 20. So now we already have a and b. We can find the question b, the answer for question b. Okay, so for question b, so we can put the value of a and b into the function, and to get the question b, what we need to do is to differentiate. Remember the properties of the cumulative distribution function. We can find out the PDF back by differentiate. Okay, because we find out the probability, cumulative probability, we integrate. So to get the PDF back, we differentiate. So the first one for the interval 0 to 2, for negative infinity to 2, okay, where x is less than 2, so we just have to differentiate 0. So differentiate 0, we get 0. And the next one for x in between 2 and 4, we differentiate ax minus 1 over 10. So a is 1 over 20, right? So differentiate x over 20 minus 1 over 10, we get 1 over 20. And then the next interval, differentiate x over 10 plus b. So the next interval is 4 to 13, right? So fx is equal to differentiate x over 10 plus minus 3 over 10. So differentiate x over 10, we get 1 over 10. Differentiate negative 3 over 10 will be 0. So the answer is 1 over 10. And lastly, to get the function PDF for x more than 13, this is 13. Okay, so the fx will be the differentiate of function z1. So here it should be 1. So differentiate 1, we get 0. So we only have two defined function at interval 2 to 4 and 4 to 13. Other than that, it will be 0. So we can put otherwise 0. So the final answer fx, the PDF, is equivalent to bracket of 1 over 20 for x in between 2 to 4 and 1 over 2 for x in between 4 to 13. So for 0 or 0 for otherwise. Other than these two intervals, the function will be 0. And lastly, for question C, they ask you to find probability of x in between 3 and 6. So on the interval, so we have 2, 4, 13. So 3 will be here, 6 will be here. Okay, we need to integrate from 3 to 6, but we have to transit at 4. Okay, you can directly integrate from 3 to 4 over function. Here, 3 to 4, we use function 1 over 20 respect to x, plus integrate from 4 to 6 over function. Here, 4 to 3, we use function 1 over 10. So 1 over 10 respect to x. So if you want to use PDF, then we do like this, just integrate. But we also can use the cumulative distribution function, where it will be capital F of 6 minus capital F of 3. But use the correct function. For capital F of 6, it will be x over 10 minus 3 over 10. Okay? Remember, capital F of x over 10 minus 3 over 10. This is for x in between 4 and 13. And then the next one is x over 20 minus 1 over 10. This is for x in between 2 and 4. Okay, substitute the value 6 and 3 correctly into the correct function. So we get the value here is equal to 1 over 4. So we can use the integration we can use the PDF that we found at part B. So let's check whether it will be the same answer or not. It should be the same, no? So if you use the PDF, means that it will be integrating from 3 to 4 of 1 over 20 respect to x plus 4 to 6 of 1 over 10 respect to x. So here we get 1 over 20 of x from 3 to 4. plus 1 over 10 of x from 4 to 6. So you get 1 over 20 of 4 minus 3 plus 1 over 10 of 6 minus 4. Here is 2, so 2 over 10, so this is 1 over 20 plus 2 over 10 will be 5 over 20, which is equal to 1 over 4. So the answer will be the same lah. Okay, so you can either use either one, but it's depend on the question. If the question for C, after we find out the PDF, the question is hence find the probability, then you have to use the PDF. So it's depend on the question, but here they didn't give any instruction, just find the probability. So you can use either the cumulative or the probability density function. Okay, so that's all for topic 8. Okay, so don't be stressful with this chapter even though you didn't understand. Later, if we want to, we will do some exercises and you will understand lah. Okay, nothing stressful about this topic because it won't be in the exam. For the assignment, you have your group. Okay, so thank you for this lecture and see you guys next class.